Good afternoon, everyone. My name's Madeline Slavsky. I'm with the Midwest Cover Crop Council. If you don't know what the Midwest Cover Crop Council is, that's a group of researchers, extension, and farmers who are working on expanding implementation of cover crops. And today we've partnered up with Iowa Learning Farm to host a series of webinars all week. This is our cover crop webinar week, the first day, where we'll go through a lot of really good management topics for cover crops. So how do we make cover crops work well? What is the research telling us? And what our field experience is telling us. So we've got a really nice topic today. We've got Dan Smith and Liz Stahl, and I will let Dan take it away. First, if you have any questions, throw them in the chat. And at the end, there will be information for claiming CCA credits. Good to go, Dan.
Great. Thanks, Madeline. Well, welcome everybody, and thanks to Iowa Learning Farms and Midwest Cover Crop Council for bringing us all together to chat about cover cropping today. I come to you from southern Wisconsin, very sunny out today, and I'm Dan Smith, the program manager for the Nutrient Pest Management Program at the University of Wisconsin-Madison. Previously, I worked as a regional agronomist with the same program. I also serve as a co-representative for Wisconsin for the Midwest Cover Crop Council Board of Directors. I'd like to introduce our speaker today. Our speaker is Liz Stahl. Liz is an extension educator in crops with the University of Minnesota Extension. She's been with Extension for over 20 years and prior to that worked in industry for over 10 years. She has a BS degree in ag education with a minor in ag economics and a master's degree in agronomy/weed science from the University of Minnesota. Her efforts focus around corn and soybean production issues, pesticide safety education, and cover crops with a particular interest in sustainability. Quick reminder, we'll have a little bit more information on those CCA credits Madeline briefly mentioned at the end of the webinar. Put those questions in the chat, please. And with that, I'll turn things on over to Liz.
All right, thanks, Dan, and thanks everybody. I do appreciate the opportunity to talk to everybody today. This is kind of one of my favorite subjects to talk about. And weed science is my background, so it's kind of neat to be able to kind of mesh that with another real significant interest is working with cover crops. And I know Dan's done a ton of work with this too. So again, great to have him moderating this session and helping out with questions at the end too. So anyway, what I want to talk about today, is managing risks when using cover or herbicides in a cover crop system. And if I get this to go, there we go. So, some people might be thinking, okay, why are we focusing on herbicide interactions with cover crops? What's the big deal here? Well, of course, farmers, hey, herbicides are a key part of conventional farmers' cropping systems, when they look at weed management. And we know, that their herbicide program does have the potential to impact cover crop establishment. And the thing is, it can be really hard to diagnose an issue like that because the whole field is treated the same. I think back to when I first started working with cover crops and some of the first farmers to try cover crops. We had some real, you know, failures of establishment and it was like, what's going on? The second year in a row, was it too dry? Was the seeding rate wrong? They were questioning the seed and all that too. And then we just started taking a closer look at different things, and it's like this light bulb goes off too. And it's like, what herbicide program were you using? And they had been using some pretty hot stuff. So again, that's kind of where this interest kind of came in that, yeah, there is a potential, not that it's going to happen every year, but there is a potential for your herbicide program to influence establishment. Also, we do know, of course, too, that your herbicide program can affect what you're able to do with that cover crop in the end. Basically, we're talking about, can you graze it or not? Also, the long-term efficacy of your weed management program. Sometimes people might think, well, if I'm using cover crops, I'm not going to worry so much if I get some weed escapes. Again, weed management, that's my background. We don't want any weeds to go back to seed. Water hemp, that's the biggest headache that our farmers have in Minnesota, and I'd say probably across most of the upper Midwest. We know that one plant can produce over 250,000 seeds per plant, so we don't want these weeds to be going to seed, even if we're, trying to figure out how to get cover crops into that system too. So again, we don't want them to negatively impact our long-term weed management program. And that's the thing too, cover crops, they can impact our options, potentially have an impact on the effectiveness of some of our products, but they also can hopefully, help us with weed control too. So we'll talk about some research that we've done, at least in the state here. And one thing with herbicides as well too, termination, that's really key too. You have to have effective termination of that cover crop. Otherwise, you can get, more competition than you want with that cash crop, ultimately, impacting the yield of your cash crop. So I did want to also just provide a little bit of background, talking about, again, why are we, trying to use like residual herbicides in a system where we're using cover crops. This is not an issue that's unique to Minnesota. We have a lot of issues with herbicide resistant weeds. And this is just highlighting a research that was just published recently out of the University of Minnesota. Basically, what was done in 2020 and 2021, we had, a grad student went out, collected samples. We also helped collect at some sites too, but over 90 different populations across the state over those 2 years. Went to fields where we had water hemp escapes. So again, this is escapes, didn't have, effective control. Took those seeds, planted them out in the greenhouse, and then those plants, we sprayed a 1x rate, so that's your normal field rate, or a 3x rate. So that's 3 times what you'd use in the field, using 8 different herbicides representing 7 different types of, sites of action. And we do have those on the lower left hand of the slide there, showing the different herbicides that were used. And again, just trying to see, what kind of survival did we have, basically screening for resistance. And if you look at these colors, we've got the different herbicides represented with the circles here, and where there's orange, those populations were considered highly resistant. So that's where at least 40% of 40% of that population survived a 3x rate, whereas if it was in yellow, it wasn't quite 40% survived the 3x rate, but at least 40% survived the 1x rate. Less sensitive, that's where less than 39% survived the 1x rate, but at least 10% survived the 1x rate. And you think about that from a practical standpoint, if that's your field, when you're getting into the 20, 30% survival, that's a failure. But again, we just called that less sensitive. And susceptible populations, those were in green. That's where less than 10% of that population survived the herbicide. So you look at these different, herbicides that we screened with, like 2,4-D, for example, 10% of the populations that we looked at came up being resistant. 2,4-D, that's the active ingredient in list one, very widely used now across the upper Midwest. 37% came up susceptible. Atrazine, we had, 47% coming out resistant. That's product been used for quite a few years. 22% were susceptible. Dicamba system, we had, a little over half were susceptible yet, but we still had 2% falling into one of those resistant categories. Fomesafen, that's the active ingredient in Flexstar, widely used to control water hemp, but we're losing effectiveness of that too. We had 31% showing up resistant, 43% being susceptible. Glufosinate, that's the active ingredient in Liberty. We had 78% of the populations were susceptible, but we had 22% were showing up to be less sensitive to glufosinate too. So that's a big red flag. That's one of those products where, again, we haven't technically found any resistant populations in the state yet. We do have, at least one population that we're really looking closely at, but we know that we can't just rely on that. We're going to burn out that chemistry too, with resistance. Glyphosate, we know we have significant issues in water hemp populations. Only 1% of those populations came up being susceptible to glyphosate. And then you look at the imazamox, that's a group 2 herbicide, so like Pursuit, First Rate fall into this. We used to use Pursuit very widely. None of the populations came up susceptible to that. Mesotrione, another product, here again, finding resistance issues, only 20% being susceptible. So the bottom line is, we've got a lot of our populations are showing resistance to key post-emergence herbicides. And again, this is not unique to Minnesota. I also wanted to highlight too what we're seeing. It's not just, in populations, we're not just seeing resistance to one herbicide. This here is looking at, for example, in green, that's the number of populations where we had two-way resistance in our water hemp. The purple is three-way, the four-way is yellow, orange is five-way, and six-way. So that's the ones in red. We had four populations that had resistance to six different sites of action. The only one that wasn't showing resistance was this glufosinate, again, active ingredient in Liberty. So we know, again, if we just use Liberty only, we're going to just select for resistance to that. So um, highlighting this because again, pre-emergence herbicides with residual activity, they need to be a key part of our weed management systems. They help us, control weeds that do have resistance to a lot of different post-emergence products. But we do know too that we need to diversify our strategies. But again, I just want to emphasize if people are thinking, I want to use cover crops, I want to toss out residual herbicides, that's, we're not encouraging that. You want to keep them as part of the system because we do have so many issues with herbicide resistant weeds. So, looking at, managing risks when using herbicides in a cover crop system, what I want to talk about would be, for example, considerations if you want to graze a cover crop, look at the potential for herbicides to impact establishment, look at potential interactions of the cover crops with weed control, and then wrap it up with looking at some termination tips. So the first question I like to always ask people, when they're looking at cover crops and looking at this cover crop question, um, if they can use it or not, is like, is a cover crop going to be grazed or fed? And if yes, you need to be following what the label says for all pesticides used. This is really key. It is a legal issue. It's a food safety issue. Those rotation restrictions, you will find those on the herbicide label. And what that is, that's that time between herbicide application and when you can actually plant a subsequent crop. And it's based on, trying to prevent having illegal residues of that pesticide in the crop. And that crop is going to get into, if it's being grazed, that ultimately gets into the food or feed chain because, animals eat it. Well, then we eat the animals or we eat the, like drink milk or different things like that. So again, it's to protect that food and feed chain and human health. It's not looking at the crop safety, those rotation restrictions. It's really looking at that food safety issue. And the thing is, on the herbicide label, if you're looking at rotation restrictions, then most all herbicides have these listed. If they'll list, the specific crops on there, but if you don't see a specific cover crop that you're planting, then it falls into what, they'll have an other crop category typically. So it'll fall into that. And then that's your longest rotation. This is a great publication, Dan. You guys put out a great publication summarizing, going through all these labels. I use this tool to help kind of narrow things down if somebody, wants to graze a cover crop and what options they have. So again, that's a great resource to use. But the bottom line is to just make sure you're checking those herbicide labels too, just in case anything changes. Now, I did throw in some examples of herbicide rotational restrictions just so you can, see how these could have an impact on when you can actually seed, a cover crop that you want to graze. And these are some commonly used herbicides in a corn soybean system. I apologize in advance to anybody who's working more with small grains or forages. I'm in southwestern Minnesota. We're pretty much corn and soybean country. That's what I work so much with. So again, I have these examples, but the principles are the same, regardless of what crop you're working with. And I should also know too, I'll use different names of different herbicides, not trying to pick on anybody, not trying to promote any products, just using those as examples too. So I always got to throw that in there too so people are, aware of that as well. But again, getting back to these herbicide rotational restrictions, I've got, some different herbicides here on the left and then the different cover crops across here. And if you look at this, and this is in months, like our cereal rye, wheat, oats, typically, when you do look at these labels, those will have, some of the lowest rotational restrictions. You typically can find these more listed too, because then they're more commonly used crops, crop slash cover crops. We've used them as both. Annual ryegrass, I have that highlighted here as well. Now that one, you'll see longer rotational restrictions for a lot of these herbicides that I've listed. And again, it could be they may not have ran all the tests, to find out what the residues could have been in annual ryegrass, or there really is a difference. But again, you have to follow what it says on the label because that is a legal issue there. And if you look off to the right, the cover crops that we have listed, like the radish, clover, and vetch, a lot of times you're going to find, not always, but for example, radish, that's a shorter rotational restriction with dual 2 magnum than our small grains, but a lot of times they end up being a little bit longer. So that's something to think about too. Why that is, again, it's the testing that was done when these labels went through and based on their results or what tests were ran. Now we had something come up. We have a program we call this Cover Crop Academy, and we were going over this kind of information and looking at these herbicide labels. This is one example, the Acuron label. And here's just a snapshot out of that, looking at the rotational crops. And you look at those intervals. So we look at, here we have 4 months that you have to wait from application till you could plant, wheat, barley, or rye. But if we look deeper on the label, they also have some cover crop language. More labels are adding what I call, cover crop language on there. It seems like some of this might be just kind of more standard language across labels, but it's important to look at that too. And I've tried to have a highlight here in a straight line, but it's not quite straight. But anyway, if you look at that here, it says after harvest of an Acuron herbicide treated crop, planting of a cover crop is allowed provided the cover crop is not grazed or fed to livestock nor harvested for food. So if you look at that language versus the rotational restrictions, which said, okay, I could, plant wheat, barley, or rye if I waited 4 months, what am I supposed to look at here? And we actually did, for clarification, just to make sure we were telling people the right thing. I talked to our Minnesota Department of Ag. They do the regulatory part, enforcing the federal and state laws. And they actually brought this out to the EPA. So got the official ruling on this, and basically what they says was what we were hoping they would say too, and it's how we've been interpreting it as well. If you're grazing or harvesting a cover crop for forage or feed, use that rotational restriction information for the species listed, because again, those species were tested when the registrants brought the labels through. They actually ran the tests on these different crops. So that's your number one information to use. Now, if you're planting a cover crop that isn't on there, that's where you'd fall under that all other rotational crops, or, using this basic cover crop language, because that's going to jive with what this all other rotational crops information is. So again, that was reassuring, at least to see that. Now I did want to also just throw in some post-emergence products that had some shorter rotational restrictions too, because again, I know when you're grazing a cover crop, that's a really great way to help pencil out cover crops. You can get some real value from that, and we have products like Basagran that's been around for a long time. There's none listed actually for any other crops. Also, like Cadet, that was all at 0. A lot of these are, they're non-residual products. They're not soil active, so again, list one very popular product, Liberty Ultra, and that's also pretty popular. So look at that. And again, I highlighted the cereal, like cereal, rye, wheat, oats, kind of our small grains tend to be a little less, compared to some of our broadleaf cover crops, if there are any differences. And the annual ryegrass doesn't always have all the same information as we do for those key, species like cereal, rye, wheat, and oats. But again, so that's just kind of highlighting it. There are options, not a lot all the time, but there are some options. So, again, if you want to graze a cover crop, make sure you're checking the herbicide labels for all the products that were used. The more species that you have in a mix, the more difficult it's going to be to meet those rotational restrictions. That's one of the challenges. I know a lot of people like to put a lot of different cover crops into their mix. But a lot of those, if may not have ever gone through all this testing, so they're going to fall into that other cover crop group. So you could have some pretty long rotational restrictions that was going to limit your ability to graze those. And if you're wanting to interseed a cover crop early in the growing season, say around V2, V4 corn, that's going to really have a limit too, just because you don't have much time that's passed from applying that herbicide till when you're seeding the cover crop. And also too, yeah, rotational restrictions, they don't necessarily reflect that potential for cover crop injury. It's really looking at the amount of residues that you might find in the cover crop. So that's what I wanted to say about grazing. But if you're not going to harvest or graze that cover crop, you're just really looking there for soil health benefits. You do have a lot more flexibility, but if you do have injury from a previously applied herbicide, you're on your own if you're not following what the label says. And there is some information out there, but I think people get frustrated at times too because it is more lacking. There's not as much out there as we'd like. But universities have done some work on this, and there's a little bit of info out there to help. But it can be more challenging. It's certainly more challenging the shorter that window is if you're trying to seed the cover crop earlier. So if you're not going to graze or feed the cover crop, again, just using it for soil health benefits, things that affect this, potential to have an impact. Well, herbicide characteristics, what's the half-life? How long does this herbicide remain active in the soil? Is it soil active or not? Is it just a, contact product where it's not going to be taken up once it hits the soil? What's a cover crop sensitivity? We know that cover crops can really vary in this. Also, when did you apply that herbicide versus when you want to seed the cover crop? How long is that time period? What rate did you use for the herbicide? And even rate of your, seeding rate might have an impact too. If you're using really light rates, um, you know, thicker rate might help you out if there is some potential issues. Soil characteristics, high pH or low pH, those extremes, depending on the chemistry or soil organic matter can, have an influence on how long, if you can have injury or not to a certain species. Environmental conditions. If it's really dry, for example, that's where we have more potential for herbicide carryover, thus also potential for issues to our cover crop. And you think about soil microbial activity, that is our really key process that is a factor in breakdown of herbicides. So whatever makes those microbes happy, that's going to help enhance breakdown. So again, kind of that Goldilocks conditions, not too hot, not too cold, not too dry, not too wet. That's going to enhance soil microbial activity. We did do some research a couple years ago at the University of Minnesota, just looking at this question. We had a real limited number of herbicides that we looked at, but again, it's kind of like a pre-screening type project to just see, are we going to pick up an issue or not? And this was looking at the impact of residual herbicides in corn on fall planted cover crops. And before I get into this, I just want to note too, I used to work for a seed company, and we, actually really tried to push the factor of, having inducing like herbicide carryover conditions. We did stuff that a farmer would not do. Again, just trying to see if we could see differences in sensitivity between hybrids and varieties to different herbicides. And boy, there were some years, I mean, you're just like, we should get carryover, and we would not get carryover. But then once in a while, you would get it. That's the thing. Herbicide carryover is very temperamental. You can't count on it, which that's a good thing, I guess. But sometimes it can hit you. So that's why these guidelines are in. There's just about that managing risk. But anyway, getting back to our study here. So we did set this up just to see if we would see any issues. We had 3 different herbicides that we looked at. This Outlook, Verdict, or Resicor, and you can see the active ingredients here of each. And then we had a treatment where we looked at applying Outlook and then came at pre-emergence and then came back 30 days later, with Outlook again as a post-emergence application. And I should note that is a key way to help manage water hemp, for example, doing these layered residuals. So that's why we included that in the study. And then we planted cover crops in the fall. So we harvested the corn silage, planted the cover crops, drilled them in. We had cereal rye, winter camelina, and red clover. And I'll note right away, I won't show data on red clover because we had some significant issues with stand, and that was stand across, where we didn't have any herbicides applied either. So we just said couldn't really make any conclusions out of that, but I can show you the cereal rye and winter camelina data. And, what there is to see, really, we didn't see any differences, in looking at the spring biomass. So this is we looked at Rochester, Rosemont, and Waseca. We had 3 different locations. And like with, you're used to looking at these statistical data, I'm sure, is just, whenever you have a bar with the same letter on it, it means it's not significantly different. So again, we had no difference in treatments, compared to no pre-herbicide versus all those treatments at all 3 of these locations for winter rye. And the same with camelina. We had a little bit of difference in how much biomass might have been at a particular site, but that was just across the average. So in these trials, we were not able to detect any differences, even though, we were pushing it with one of those treatments by having, that outlook followed by outlook 2. So again, summary from our trials, like, may not have an impact, but it is something to always watch out for. This is a resource I encourage people to take a look at. It's off this iwilltakeaction.com website. They have a nice little publication looking at herbicide persistence and carryover to cover crops. It summarizes a lot of the research that's out there right now on, potential for herbicides to have an impact on stand and biomass of cover crop species. For example, they've got these tables. I'm not going to list all these different herbicides here, but you can see the ones that they have listed on the left, and then they show, fall cover crops that are generally should be safe to plant, fall cover crops where there'd be potential for injury, and they have, here's the remaining number of the herbicides that they've looked at too. So a lot of are commonly used herbicides, and they're looking at, a single active ingredient. There's a lot of generics and mixtures of these products. But again, this is a nice little resource, but note that it is fall planted cover crops, not trying to look at if you're early interseeding, because that's a shorter window, greater potential to have some injury. This is also a nice little resource that was published too by our neighbors here in South Dakota. They have herbicide residual effects on cover crops after corn silage. And here in this table, they just list some of the different products where they did not see an impact on cover crops that were planted following, harvest of corn silage. So again, some nice little resources there. So kind of the general consensus when you look at all this research tool too is that, there's differences in sensitivity. And I know Dan's done a lot of cool work on this too. But, when you look at the different cover crops, like tillage radish, for example, that has tended to be, the most sensitive. And then as you go down this line, all down to cereal rye, that has tended to be, our one that's least sensitive. So it tolerates, most of the herbicides that people have looked at. Makes sense too, because, cereal rye is a crop too. So, it's probably been bred to handle that system. That would be my guess anyway. And they also talk about here, just kind of looking at all the data, soybean herbicides that tend to be the most injurious. Here's like the active ingredient Flexstar. Here's imazethapyr, that's active ingredient Pursuit. Acetochlor, a lot of pre-emergence herbicides, sulfentrazone, for example, in a lot of different pre-emergence products. And then corn herbicides that tend to be most injurious, they have a list of those as well. Again, encourage you to take a look at that resource if you do want to get a list of this. And then other things too, just a general guideline, residual herbicides that control grass weeds, they do have the greatest risk to affect grass cover crop establishment. That makes sense. And here's some of the broadleaf cover crop species. They tended to be most affected by, our group 2 herbicides. So that would again like be Pursuit, First Rate, for example. Our group 5s, those would be like atrazine. Group 14s, that would be like Flexstar. Group 27s, that would be like Callisto, Lotus, and so forth. And also, risks were greater with earlier planted cover crops. So again, early interseeded, because again, you just don't have a wide enough window between application and seeding of that cover crop for that herbicide to break down. And also look at weather conditions, soil types, herbicide program, and cover crop sensitivity when you're deciding, what to do in your own cover crop system. And I do want to emphasize this too. There have been a number of growers that I've worked with, and they're like, hey, I took care of this issues because some who did actually have issues with carryover, they're like, well, now I just use a reduced rate of herbicide, which just makes me cringe too, because again, reduced rate of herbicide, you could very well get reduced weed control. You still might get injury of that cover crop. And that is a great way to select for herbicide-resistant weed populations. This is just some research cited on Palmer Amaranth, where they use low doses of dicamba over 3 generations. They found a threefold increase in the rate needed for control. Again, we just know that, yes, based on long experiences too, if you're using reduced rates, that is a great way to select for weeds that are tougher to control with that herbicide and ultimately resistant. So we don't recommend that. You don't want to throw away good weed control just trying to make something else work. Try a different product, try a different cover crop, do some other tweaks elsewhere. So looking at, potential impacts and interactions that cover crops could have on weed control. I just want to show a little bit of research and work we've done there. This is some research done at Rochester and Lamberton. So these are in southern Minnesota over the last couple of years. They were established in the fall of 2021, and then we collected data in 2022 and 2023. We had 4 different seed, well, one was a control, and then 3 other seeding rates of cereal rye, so 60, 90, and 120 pounds per acre. We looked at terminating the cereal rye 7 days before planting, at planting, or 7 days after planting. At planting, we also had the option where we looked at adding a pre-herbicide, and that was verdict at the time of termination. So we could look at that impact of adding that pre-herbicide in there. We had 2 different soybean planting dates. Early, we called early May 15th, even though that's really not that early, for us, really more like May 1st would be an optimal planting date for soybean. That's when we know we can optimize yield. But based on the year, it was one of those years we just couldn't get in. So our early planting dates ended up being, May 15th, and the late was June 1st. And this crop rotation, we had silage corn followed by soybean. So we seeded the cereal rye by drilling in late September to early October. So looking at, how much biomass is needed for weed control and, what impact is our herbicides having with this? Because again, one of the key reasons we use cover crops too is to help us with weed control. Well, this is data again done by Eric Yu, one of our now a crops educator also with the University of Minnesota. And if you look at the plots, so this is that individual data plots from each plot. We're looking at percent control based on biomass. And sorry that this isn't kilograms per hectare yet, but just use that conversion rate of 1 kilogram per hectare is like 0.9 pounds per acre. So if we had 5,000, and that's about where that red line is, kilograms per hectare, it's about 4,500 pounds per acre. So you look at, again, these data plots, we got up to about 90% weed control, and that's, getting more in that acceptable range once we got about 4,500 pounds per acre. But I also want to look at all that variability and percent control based on, how much biomass we had. There's a lot of variability when we didn't have a pre-emergence herbicide. But when we did use that pre-emergence herbicide at termination, look at how that data tightens up. Even at those lower rates of biomass, we're getting better control. And once we kind of average out at 90% or more, that was about, 25 to 22 and a half, about 2,250 pounds per acre came out to be. So we needed less biomass to reach that 90% weed control when we used a pre-emergence at planting than if we didn't. Because, again, how do we achieve, when we're trying to get like that 4,500 pounds of biomass, that's said a lot of times is that's the amount of biomass that we need to get weed control. Well, that's really challenging to get in Minnesota. May not be as tough to get further south where you have a longer growing season, but it is tougher for us to get up here, further north. And so here's results from Lamberton on the left, Rochester's on the right. On the very left, we have our early planted soybeans, and then next to that is our late planted soybeans. This red line, that's where, we got about 90% control because we're reaching about that 4,500 pounds per acre of biomass. And we only got, that amount of biomass once we had that 7 days after planting with the late planting at Lamberton and the same thing that we saw at Rochester. So it was very tough to reach that level of biomass. However, to reach the amount of biomass that we needed to get 90% control when we were using a pre-emergence herbicide, there, we reached that with the early planted soybeans. So again, earlier termination of the cover crop, but we're also planting earlier of our soybeans. That was when we terminated the cover crop 7 days after planting and that early planting at Lamberton. But also when, all the treatments, we were able to reach at least that amount of biomass with the late planted soybeans. Because again, late planted, we allowed more time for that biomass to accumulate. And at Rochester, we weren't able to get that with our early planted soybeans, but with our later planted ones, we did with the three later treatments versus the very first one. And it's also important to note here too, we had that component of seeding rate in here. We didn't find any difference in results between 60, 90, or 120 pounds per acre. That did not influence spring biomass production, so that's important to look at too. And I should note, this isn't a conventional system. I know sometimes organic growers will grow higher amounts of cereal rye because they don't have other herbicides to use in the system. But in our conventional system, yeah, we didn't see an advantage to using rates higher than the 60 pounds per acre. Also, cereal rice seeding rate did not impact weed control or soybean yield. And I just thought it'd be really interesting to show this too, because again, kind of the conventional wisdom has been, oh, we need to hit that 4,500 pounds per acre of biomass to get weed control. Well, we did find, here we've got water hemp control on the left. We did get at least 90% control, and you'll see highlighted in yellow, those are our top treatments with the top water hemp control in that early planted soybeans when we used, the pre-emergence herbicide, if we terminated the cover crop at planting, and also if we did it 7 days after planting. Same with that late planted, we were able to there reach it with the at planting termination and the 7 days after planting. And at the bottom here is just showing you how much biomass we had or the cereal rye at that time too, and this is in pounds per acre. So again, we didn't need to reach that high amount, that 4,500 pounds per acre when we use that pre or, played around with that termination time a little bit later. And soybean yield, this is, of course, is important to look at too, because, for planting soybeans later, so terminating the cover crop later, trying to get more biomass, well, we can have a yield impact too, especially, in our neck of the woods where we have a shorter growing season. And you look at yield, we optimize yield by, the early planting. That was higher yielding than any of our later planting timings. And when we terminated the cover crop at planting, with or without the pre, and that's 7 days after termination. So that's where we optimize our soybean yield. And another question too, when we're using pre-emergence herbicides in the system that comes up too is, well, what impact does all that biomass have on, the ability of that pre-emergence herbicide to hit the ground? Because it has to hit the ground, because that's where your weed seeds are germinating. So if it's being intercepted by that cover crop, are we going to get the same amount of weed control? So they took water sensitive paper, placed this out in the plots, and they made applications. Across the top is that early termination. So, overall we had less biomass. The bottom ones are the late termination, and we've got the seeding rate of cereal rye at 0, 60, 90, and 120 pounds per acre. And you'll see at the early termination, we really didn't see much difference. And, where the black is, that's where the product would hit the soil. Whereas in the late termination, okay, you look at the, no cereal rye, we had a lot of product, hitting the ground, but, at 60, there was a lot more, being intercepted by the cereal rye. And then the 90 and 120, I'm not really sure if that's actually statistically different or not, but it looks like it's a little bit less, the interception by the cereal rye biomass. Now, Does that have an impact on control? We don't really know that. That's one piece of the puzzle we don't know, but it is just something to think about that, yeah, we do have more interception. So far in other research that I've seen, it hasn't necessarily had an impact on yield, even though you're getting more intercepted, but you can assume too, if there's a point where if it's all getting intercepted, yeah, it probably would affect impact of that efficacy of the product. But again, so that was just interesting. We did see a little difference of that with the seeding rate at that late planting. Now, again, looking at trying to optimize our biomass production because, optimizing biomass production, that's where we get our most soil health benefits by the more biomass typically. That's been kind of a general guideline. Plus, also generally, we get better weed control with that too. This is some work done at Lamberton, Axel Garcia. We had multiple sites of this too, but this is from the Lamberton site, just showing you, how fall seeding date matters too with cereal rye, at least certainly in Minnesota. This was, we had up in the upper left, we seeded the cereal rye at September 4th versus September 16th versus the 24th versus October 5th using my highly scientific method of gauging height of my clipboard. And you can at least just kind of see what the differences were in the height. And we actually, in that first seeding date, we had about 3,700 pounds per acre, which, for us, that was one of those unique years like, wow, we actually did get a lot of biomass. This was at planting time at May 18th. And I'll show you the results here when we look at actually with running the statistics. Now, this one, the darker green bars, I guess green, teal, whatever color you want to call that, but the darker ones, so that was when we terminated the cereal rye on May 6th. So look at the statistics within that. We saw the biomass go down when we seeded like October 5th. But those earlier seeding dates were all similar. And then when we terminated on May 18th, there, again, we saw those earlier seeding dates, September 4th and 16th, those were similar. And the amount of biomass did drop off on the 24th. And again, October 5th, that last seeding date, we did have lower biomass in the spring as well. We saw similar results in 2022. Here again, earlier seeding, got us more biomass. It actually dropped off. We had September 10th. Once we got to later September, we found a little decrease. Was similar to the October 4th, and the October 11th seeding was lower. And again, kind of similar trend there with that second termination date. So again, that's the thing. If you're trying to optimize biomass, look at that seeding date too. That's why a lot of seeding cereal rye after corn silage does help us out because we're able to seed it earlier. General consensus has been if you can seed it by September 15th, even into the end of September, that's really ideal versus waiting later on if trying to optimize that biomass. Now, one other point I want to highlight here too is just effective termination is key. This is a field that I had driven by a couple years ago, and I was like, what is going on here? And finally I did stop one day just to run out there and just take a look. And I'm not really sure what happened with this application, but you can see there are strips where they did have effective termination of the cover crop and others they did not. I don't know if they, came back later. I'm really intrigued to see what the yield would have been on this. But when I did go out there to look too, where they didn't have the cereal rye effectively terminated. The soybeans are really spindly, very spotty and stand. Yeah, I expected a very significant impact on yield. So again, effective termination is key as well. So that's another piece we got to look at when using herbicides in our cover crop system. If you're, terminating with a herbicide. So this is some work that Devlin Sarangi, he's our extension weed specialist, did with Eric Yu to again, looking at different types of termination methods and which would be most effective. Did this at Lamberton and Rosemont. Lamberton again being southern Minnesota, Rosemont be more in central Minnesota, and the graph on the top, that is when those crops, or excuse me, the cereal rye was terminated at tillering. And in the bottom, the one that's orange, that's when it was terminated at heading. So we've got our different treatments across the bottom here. And if you look at what I circled in green here, those are all the treatments that had Roundup. And, bottom line was using Roundup for terminating a cover crop. That was our most consistent treatment. We did look at mowing, and you can see at both timings just was not that effective. We had to do multiple timings, tillage, maybe at tiller excuse me, at heading there, it did get up to the other ones as most effective, but it was certainly not earlier on tillering. The thing is too, when you're doing tillage, you're kind of wiping out the benefits of having a cover crop out there too. Something to think about. I also want to mention too, Liberty, again, great product. Um, Great thing to have in the system, but it is not a product I would recommend you use early on in the season to try to terminate a cover crop because it needs to have, warmer temperatures, sunny conditions, which we don't usually get when we're trying to terminate a cover crop. So save that product till later in the season. But yeah, something with Roundup, that's been our most consistent at termination. And here's just some of the pictures. You can see this is 14 days after treatment. Here the mowing, we're getting regrowth. Here's the Roundup. It worked very well. Liberty, we didn't get effective control. On Select Max, that's a grass herbicide. We did not get effective control either. So again, effective termination is key. This question comes up a lot of time. What about roller crimping? We have not done a lot of research on this at the University of Minnesota. We did a trial like many years ago before my time, and I still hear about it now. Didn't work very well. It's not very effective. Timing is everything with that. You really need to get the cereal rye when it hits anthesis, when that pollen's starting to shed. So that's why I put a question mark. I've talked to various farmers. Some have been able to get pretty decent control with this, but it's kind of a question mark too. But it is another method out there. Organic systems, yeah, you don't have a lot of options for termination, but roller crimping in our conventional system, it's just been more inconsistent is what we've seen and heard. Now, I also would be remiss if I didn't say anything about the potential greenbage issues you can have, if you're like planting green with cover crops. So, for example, like true armyworm, we have had issues with this in Minnesota. It's not something you see all the time, but there is potential for it to happen. So basically, true armyworm does not overwinter in Minnesota, comes up from the south. Typically, the moss, like when you have a thunderstorm or something, that's when the moss come down with the precipitation. They're attracted to grassy areas. So, think a rye cover crop that's growing. Now, they lay their eggs there, then the larvae hatch, they're munching on the rye cover crop. If you come along and plant, your corn into that, then you terminate that cereal rye. Well, the larvae that were feeding on the cereal rye, well, now they're going to go, hey, I'm hungry. And they're going to go over to the corn and start munching on that. And Claire, she is on this call as well today. These are some pictures from her, pretty striking. I understand this is like 3 days. This corn looked terrible like this. So, yeah, dramatic impacts on yield. And we've also seen things happen in soybeans. Soybean is not a preferred food source for armyworm, but if they're starving, they're going to go after what they can get. So just encourage people, make sure you're scouting for this. It is something you can, apply an insecticide to control if you do have issues. Also watch, that we do monitoring of seeing when those flights come and when, you might expect to see feeding issues. So kind of to wrap things up here again, in summary, yep, follow the label if you're grazing a cover crop. That's imperative. Check your resources if you're not grazing a cover crop. There's a lot of information from universities, and this Take Action website has some nice tools. Cereal rye in general has been one of the most tolerant species overall, though, when we look at these different cover crops too, the potential for carryover. Make sure you get effective termination of the cover crop. We want to protect our crop yield too. And balance those goals of optimizing your biomass with optimizing crop yield. We didn't need to hit such high levels if we used a pre-emergence herbicide, and targeting early seeding as we can in the fall. That will help us get more biomass too. And again, we didn't see any advantage to using over 60 pounds per acre of cereal rye in a conventional system. And overall, I didn't present much data on this, but yeah, planting green, it does just carry less risk in soybean from a yield standpoint, insect issues as well too, just disease issues in soybean than in corn. But with that, I thought I'd wrap things up here and see if anybody has any questions.
Great job, Liz. Thank you for the wonderful presentation. We have gotten a couple questions in so far. The first one is, do you suspect allelopathy from cereal rye helped out with weed control since biomass doesn't seem to have an impact? That was in some of the earlier work that you showed.
Oh, well, okay, so biomass, we have seen cereal rye have an impact on yield. I didn't show, or not on yield, excuse me, on weed control. Um, we have seen, because again, like shading out the weeds can be part of it. So we have seen some of that too. In allelopathy. Boy, I don't know, Dan. That's one of those nebulous things, right? It's so very hard to really say. Some people say, yep, they've definitely seen it. Others, have not. How much allele chemicals are released by the roots? It's, way back when I was in grad school, we were trying to study that too, and it's been really tough. So it's not something I would count on. I think there's potential out there. But I wouldn't count on that. But yeah, I'm not sure exactly what the question was, but we have seen that cerealized biomass can inhibit, weed emergence by, you think about shading out weeds and so forth. So there is potential for that. Um,
Yeah, absolutely. And I think bringing up the allelopathy point is really great because an allelopathy is can be essentially a herbicide we have applied, but we don't know the application date, we don't know the application date, and we don't know when it's going to be activated necessarily. After um, the cover crop's terminated is usually when the plant gives off the most response. But
mhm.
we've seen a lot of interactions with biomass and a lot of um, questions about allelopathy in Wisconsin as well. So certainly not alone,
Yeah.
and I think it's something that we should all spend more time researching.
Yeah. It's very, very tough to do, but could be something there, but I wouldn't put all my eggs in that basket right now either. But
100% agree. What about the rye seeding dates, Liz, for the study where we had 4,500 pounds of biomass is kind of our peak point where we need to get to, and then also the wonderful pictures you showed of the seeding date work with the clipboard showing those different heights. What are we telling farmers to actually use out in the field for seeding rates if we can adjust timings?
oh, for seeding rates or seeding dates?
Seeding rates
Oh,
based on the time.
okay, so seeding rates, yeah, and right now that is one thing. The We typically have done most of our work at a base of 60 pounds per acre or looked at higher rates. We have not seen an advantage to using higher rates than that. Really, and actually some of those higher rates, boy, can be really tough to plan into that if you're planning late. And yeah, we've had planter issues with that too. Farmers have bigger equipment than we have, but just sometimes you can't get the down pressure that can take up more moisture. But those lower seeding rates, that's an area that I'm really intrigued by. We don't have a lot of data on that yet, but yeah, that is one area I'd like to see. Can we go lower and what impact can that have on weed control? A lot of people throw out like, hey, why aren't we doing like 30 pounds or 45 pounds or 20? I mean, there's just a lot of different rates you could look at. But then you got to think about, okay, what's your fall like? If it's a really dry fall, that's probably not a year I'd want to be skimping a lot on. Like saying, I'm going to try 20 pounds per acre. What are you going to have come up? So it's just some things you got to balance out too. But I do think there's potential at those lower seeding rates. I don't know, Dan, if you've done some work with the lower seeding rates as well, again, that's the big question. Yeah, somebody wants to fund that research. That would be awesome. That's always a challenge, right?
Yeah, we just don't know what the ideal timing and rate would be for maximum weed control. We know that number that's been now well established at 4,500 pounds, but still a lot of questions around that. And as you brought up, the planting into the biomass is sometimes the biggest challenge rather than the fall establishment and spring biomass. The last two springs
Yeah.
we've seen phenomenal fall and spring biomass accumulation because of really warm temperatures through November and really warm temperatures in March and April. So we'll see what.
Yeah. Well, and yeah, and you just remind me too, with that 4,500, that's what was really nice with that research that was done too in Minnesota is when they used a pre-emergence herbicide at planting time, with the termination timing. Then we didn't need to have, reach that 4,500 pounds of biomass to get the same level of weed control, because we had that pre-herbicide to help us out too. So it's just kind of another tool in the system because it is tough to do that. But yeah, a seeding date of the cereal rye can be a huge difference too. You got to have the moisture as well. But I know I've talked with some growers and they were trying to like seed cereal rye like in December and just wondering why they weren't getting much, advantage from the cover crop. I'm like, well, I think you need to try a little earlier. Of course, if you're in a, corn for grain, soybean for grain, that makes it tough to seed it in September too. So, possibly seeding it, when the crop has reached physiological maturity, but then you're not going to get that seed to soil contact with a drill unless it's an early harvest time. So there's a lot of things to weigh out with this. But, the bottom line is that if you can seed it by the end of September, you're setting yourself up better. And ideally, boy, if you could seed it before you get an inch of rain, you're golden, I think, for establishment. But getting rain is really key too.
Absolutely. Well, we did have another question come in, and that's in the cover crop and pre studies. I may have missed it, but was there a treatment with only pre and no cover crop?
Uh, Trying to think back to what this was. So is this, wonder which one they're talking about. Oh, okay. Cover crop and pre-studies. Oh, so that must have been when we were looking at the winter camelina and the cereal rye. We did have, I'm trying to think what we had in that trial again. It's been a while, since we did that. But we would have had, yeah, we looked at, again, we're looking at yeah, we had no pre's, and then we had a pre and we had no cover crop. We had the different controls in that trial.